All right, today we're diving into a real breakthrough in how we secure the code that's running pretty much the entire modern web. We're talking about a brand new tool called WALTZZ, and it has a completely fresh way of hunting down hidden bugs in one of the most important technologies you've probably never heard of.
I mean, think about it for a second. It's a pretty terrifying thought, isn't it? You're just browsing, you click on a link, and boom, some malicious code that's supposed to be trapped in your browser tab tries to break out and start messing with your computer. This is the high-stakes game of browser security, and it's why making our browsers totally bulletproof is so important for all of us.
So, to really get what makes WALTZZ so special, we first need to pop the hood and look at a technology called WebAssembly, or Wasm for short. You can think of it as this invisible engine that's making the modern web faster and more powerful than ever before. So what exactly is WebAssembly? Well, just imagine it's like a turbo boost for websites. It lets developers run these really complex, heavy-duty applications. We're talking video games, 3D modeling tools, you name it, right there inside your browser, at speeds that feel like they're running directly on your computer. It's a total game changer.
And this stuff is everywhere. Seriously. Chrome, Firefox, Safari. Every browser you use has it. It all runs inside this special, secure little box called a sandbox runtime. It's designed to be a fortress, you know? But if that fortress has even one tiny little crack in the wall, the whole system could be at risk.
And that brings us to the big problem. How do security experts actually test the stuff for weaknesses? Well, their #1 tool is something called fuzzing. But when it comes to Wasm, fuzzers have basically hit a brick wall.
Fuzzing is, for lack of a better term, the art of controlled chaos. You just throw mountains of random, garbled, nonsensical data at a program to see if it'll crash or freak out. It's kind of like shaking a vending machine really hard to see if anything breaks or falls out. It's usually super effective. Usually.
But here's the catch. Wasm isn't just some random program. It's a language with incredibly strict grammar rules. It's what's called stack-based. And all you need to know is that this means every single command has to perfectly follow these rigid rules about the data it uses and the data it produces.
So here's the core issue. Traditional fuzzing is like taking a perfectly written sentence and just randomly changing letters. What do you get? Gibberish, right? Well, the Wasm runtime acts like the world's strictest grammar checker. It sees that nonsense, immediately says, nope, that's invalid, and throws it out. The test gets rejected before it even has a chance to find any of the deep, interesting bugs. And the scale of this failure is just wild. Get this, when researchers used one of the best fuzzers in the world on Wasm runtimes, more than 98% of the tests it created were instantly rejected as invalid. 98%. That's just a colossal waste of time and computing power.
So how in the world do you get around that? Well, this is where WALTZZ steps onto the stage. It's a completely new kind of fuzzer built from the ground up to speak Wasm's strict language, and it does it with this really clever trick called Stack-Invariant transformation.
Okay, this is the secret sauce right here. Instead of making random, nonsensical changes, WALTZZ actually understands Wasm's grammar. It knows that it can take out a whole chunk of code and swap in a completely different chunk, as long as the new piece has the same grammatical effect. It's not about what the code does, it's about making sure the data types it leaves behind are exactly what the next instruction expects.
Let's go back to our sentence analogy. Old-school fuzzing was swapping a noun for a jumble of random letters. WALTZZ, on the other hand, swaps a noun for another noun. The meaning of the sentence totally changes, which is perfect for testing, but the sentence itself is still perfectly grammatical, so the runtime accepts it and lets the test continue.
Here's a really simple way to picture it. On the left, you've got a block of code that does some math and ends up with one specific type of number, called an I64. WALTZZ is smart enough to replace that whole block with the code on the right. It does totally different things, but it also ends up with just one I64 value. The runtime sees it, says, yep, that's valid, and the fuzzer gets to explore a whole new part of the program. And WALTZZ is no one-trick pony. It uses this amazing core idea to power a whole symphony of different tools, what they call mutators. These are all just different, really intelligent ways of changing the code while always following the rules. It's got a whole toolkit. Some mutators mess with the program's decisions. Others swap out the actual math it's doing. There's even one that can Frankenstein together pieces of code from totally different test cases. And, maybe coolest of all, it can just generate brand new, super complex code from scratch, all while making sure it's 100% valid.
So, all right, the big question. Does this fancy new approach actually work out in the real world? Well, the researchers put WALTZZ head-to-head with the best fuzzers out there, and frankly, the results are stunning. First up, let's talk code coverage. That's basically a measure of how much of a program's logic a fuzzer manages to explore. WALTZZ explored over 12% more code than its closest rival. That's a massive improvement. It means it's reaching places inside these Wasm runtimes that other tools just can't get to.
But exploring is one thing. Finding bugs, that's the whole point. And on that front, WALTZZ knocked it out of the park. It found 20 brand new, undiscovered bugs across 7 different Wasm runtimes, the same ones being used out in the wild today.
And we're not talking about minor typos here. Of those 20 bugs, 17 of them were serious enough to be given official CVE numbers. That's the official stamp for a real, recognized cybersecurity vulnerability. This thing has finding bugs that really, truly matter.
Let me just give you one quick example. There was a bug WALTZZ found in a runtime called Wasm 3. The developers said it was difficult to detect under normal circumstances. It was a deep fundamental flaw in the core design that required them to make major changes to their code to fix it. This is exactly the kind of dangerous ticking time bomb that WALTZZ was built to find. Ultimately, the story of WALTZZ is more than just about a cool new tool. It's a huge reminder that as our digital lives get more and more complex, we can't just keep using the old methods and hope for the best. We have to get smarter. We have to learn to speak the language of the very systems we're trying to protect.